Here we are to do some gravimetric analysis problems. Now these get a little long and complicated. You're going to want a calculator for sure, and you're going to want a periodic table nearby because this is going to combine all of the information that we have done before. So what we are trying to do here is we are trying to precipitate out iron carbonate. And according to this is FeX and CO3 I don't know what it is actually. CO3Y, I should say. So it's FeX and then CO3Y. Remember what we want here is we want the moles of that, we want the moles of that. A couple things to remember. If you know what the charge of the carbonate ion is, you can kind of figure out what your two answers are going to be. So remember, it says it's either Fe plus 2 or Fe plus 3. So your two choices are Fe plus 2 with the CO3 minus 2 if you've got your ion list, and the Fe plus 3 with the CO3 minus 2 if you've got your ion list. So your choices are either FeCO3, which is a 1-to-1 ratio, Fe1 and CO3 or your choices are Fe2 CO3 which again would be Fe2CO3 a 2-to-3 ratio that's there. So it's one of those. I don't know which one it is. It's one of that one or that one. But we're going to figure it out using the information that we have here. So it's either a 1-to-1 ratio or a 2-to-3 ratio. So let's figure it out. We need the moles of X and we need the moles of Y that are there, and then we can figure out which one it is. All we have to do is get those two numbers. So they kind of give you one right here in the start. They kind of give you the X. Why? Because they give you 25 milliliters of 0.1 molar, and they tell you that it's iron nitrate that it's here. So you know what the iron is from this situation. So let's work on the iron. So just from the iron's perspective, we know that it is 25 milliliters of 0.1 molarity of our iron plus question mark. I don't know what that is. But if I know milliliters, I know liters, and if I know molarity, then I know the moles per liter, so I can work this out. So 25 milliliters is really 0.025 liters. You should be okay with that. And it's 0.1 molarity here, so you should be able to plug these into molarity is equal to moles per liter. And you've got a 0.1 molarity, and that's going to be equal to the moles that we don't know per 0.025 liters. Solve for the moles. So the moles of the iron turns out to be 0.1 divided by 0.1 times 0.025. That's going to be 0.0025. So 0.0025 moles that are there. So that number we can take and put right into our equation up here right now because we just calculated the moles of the iron. So I'm going to go ahead and do that. I'm going to go ahead and put in that the iron is 0.0025 moles. Now all we need to do is figure out what the Y is. And it's either going to be the same, 0.0025, because it's a 1-to-1 ratio, or it's going to be 3/2 as much. We'll find out. How are we going to do that? Well, they told you that we precipitated out 0.29 grams. So we precipitated out 0.29 grams of iron carbonate. All right, well, what does that tell us? Well, that tells us that we have FeXCO3Y as 0.29 grams. That's both the iron and the carbonate. Well, how much of it is iron and how much of it is carbonate? Well, we don't know, except we kind of do because we did this work up here. We found out that there were this many moles of iron in the situation. Well, if I know moles of iron, then I know grams of iron because I know how many grams there are in a mole on the periodic table for iron. So all I have to do at this point is take my 0.0025 moles of iron and multiply it by its molar mass. And if you look that one up on the periodic table, it's number 26. It weighs 55.85 grams per mole. So we multiply that by 5585 and we get 0.1396 grams of iron. All right, so that means of the 0.29 grams here, that is the iron and the carbonate, we know how much of it is actually iron. So we're going to subtractify out 0.1396 grams of the iron. And when we do that, you end up with 0.150 grams of the carbonate ion, because these two numbers here have to add up to be the 0.29 that goes there. So if I know that it is 0.15 grams of carbonate, all I really need to know now is the moles of carbonate. Well, if I know grams, I know moles. So this is going to be times 1 mole per this guy's molar mass. So you get out your periodic table. And carbon is a 12 and oxygen is 16, so that's 3 times. So all of that adds up to be 60. So that stuff weighs 60 grams per mole. So we're going to divide this by 60. And when you do that, you end up with an answer here of 0.0025 moles of the carbonate. Oh, look at that. It all worked out. So the 0.0025 moles of the carbonate is going to come right back up here. And so our carbonate, we can put that number in. It's also 0.0025. So what is then the ratio of these guys? Well, obviously, if I divide by the smallest number, which is the same, then I get a 1-to-1 ratio out of this. So it's Fe1CO31. So of our two choices that we started with over here, it's pretty obvious that the choice that we are left with is this guy, because we ended up with a 1-to-1 ratio. Number 2 is identical to number 1, just a different set of problems. So what are we doing? Well, we're going to do chromium and phosphate. So that means we're going to have chromium with a plus question mark, and we're going to be reacting it with phosphate, which is a -3. Check your ion list. Again, you don't have to memorize those, although it's a pretty good idea to have a few of them, the more common ones at the tip of your head. So it's telling you that it's either a +2 or a +3 for your choices. So what are the possible outcomes of this? Well, if it's chromium with a +2 and phosphate with a -3, then you would end up with Cr3PO4 2, and you would have a 3-to-2 ratio there. But if it's chromium with a +3 and phosphate with a -3, then those would just cancel each other out, and you would have Crpo4, which would mean that you would have a 1-to-1 ratio, because there would be 1 chromium for every 1 phosphate based upon their charges that are there. So you are looking at either a 3-to-2 ratio or a 1-to-1 ratio again. So now we do the exact same things. So what we're going to do now is we're going to do CRX and PO4 Y. We need to know the moles there and the moles there, and then we're in good shape. So what did they tell us? Well, they told us that we had 10 milliliters of our chromium compound. 10 milliliters of 0.2 molarity of our chromium compound. Easy breezy mac and cheesy. So for our chromium, we have 10 milliliters of 0.2 molarity of our chromium plus question mark. If I know milliliters, I know liters. This is 0.010 liters. Again, you move it 3 decimal places to get to there. And if I know the molarity, 0.2 moles per liter, I can use my equation. Molarity is equal to moles per liter. And so my molarity is 0.2 molarity. My moles is my question mark. That's my X. My liters is 0.010 liters. So I'm going to end up with 0.2 at 0.01, 0.002 moles. So X is 002 moles of my chromium. So now that I know how many moles of my chromium I have, I can come right back up here and plugify them in. This is 0.002. Now, remember, we either have a 1-to-1 ratio or a 3-to-2 ratio. So we are looking for either the same number here, 0.002, or 2/3 of that number based upon what our information is. So what's happening now is they are precipitating out apparently 0.294 grams of chromium phosphate. So we come down here and we know we have 0.294 grams of chromium X phosphate Y. In order to get the phosphate, I have to subtract out the chromium. No problem, because I have 0.002 moles of chromium. So if I have 0.002 moles of chromium, I can multiply that times its molar mass. Look on your periodic table. And that's going to be 52 grams per mole from the periodic table. And that's going to be 0.104 grams of the chromium plus question mark. So that means of this compound here, 0.294 grams, we're going to subtractify out 0.104 grams of the chromium, which is then going to leave us with 0.19 grams of phosphate. So if I know the grams of the phosphate, I know the moles of the phosphate. All I have to do is add that up. Phosphorus is 31, oxygen is 16 4 times. So 16 4 times and a 31 gets me a 95. So I'm going to multiply this by 1 mole per 95 grams. And I'm going to get 0.002 moles of the phosphate. So now I know how many moles of phosphate I have. So I'm going to take that number and I'm going to bring it up here. So not only do I have 0.002 moles of chromium, I also have 0.002 moles of phosphate. So once again, we are at a 1-to-1 ratio for these guys. So coming back up here then, it's the 1-to-1 ratio. So it must be that the chromium is a +3 charge. Number 3 is more of the same, except this time we're going to make some cobalt carbonate. So apparently our choices for cobalt are +2 or +3. So we've got cobalt with a +2 or cobalt with a +3. That's going to be reacting and forming a precipitate of the carbonate ion. So that's going to be CO3 with a -2 and CO3 with a -2, which means if it's the cobalt +2 with the carbonate, that's going to give you cobalt carbonate, and it's going to be a 1-to-1 ratio. If it's cobalt 3 with the carbonate, you're going to end up with CO2, CO3, 3, and you're going to end up with a 2-to-3 ratio. Sounds familiar, right? So what do we need to know? We need to know what the moles of each of these guys are. So we've got COX and CO3Y. I need to know the moles here, and I need to know the moles there. What did they give you? They gave you 20 milliliters of 0.15 molar of the cobalt. That is there. No problem. So for the cobalt, I have 20 milliliters of 0.15 molarity. If I know milliliters in molarity, then I know liters in molarity, so I know moles. So I'm going to take these milliliters, and I'm going to 1, 2, 3 this 0.02 with the liters. So this is 0.02 liters at 0.15 molarity. So remember that molarity is equal to moles per liter. So you end up then with 0.15 molarity is equal to is equal to X over 0.02 liters. So our 0.02 liters, make that look a little nicer. So we can figure out what our X is now. So it's 0.02 liters at 0.15 molarity. So X is equal to 0.003 moles of the cobalt. I can take that and put it directly into my equation over here because I know now the moles of the cobalt. So this is 0.003. All I need to know is that Y, and I'm in good shape. What did they give us? They gave us that it was 447 grams of the cobalt carbonate. So I'm going to come down here, and I've got 0.447 grams of cobalt carbonate. And I'm going to want to subtract out the cobalt so that I'm left with the grams of the carbonate. How do I get the grams of the cobalt? Easy. I have the moles of the cobalt. All I have to do is turn those moles of the cobalt into grams of the cobalt. You check out cobalt on the periodic table, and it weighs 58.9 grams per mole. So multiply that guy by 58.9, and you end up with 0.1767 grams of the cobalt. So you take that down here. So it's 0.1767, if I've got my numbers right. So of the precipitate, which is cobalt and carbonate, that much of it is cobalt, so we can figure out now what the carbonate is. So 0.447 minus our cobalt is going to get us 0.2703 grams of the carbonate. Remember that carbon weighs 12 and oxygen weighs 16 3 times. So add all of that up and you get that the carbonate weighs 60 grams per mole. So I've got the grams. I divide it by its molar mass, 1 mole per 60 grams. So that's going to give us 0.0045 moles of my carbonate. So I come up here and I take my 45 moles of carbonate, and I plug it into here. So this is 0045. This one's not the same. The other two were the same. This one's not. No big deal. You divide by the smaller of the two numbers. So I'm going to divide this by 003 and divide that by 003. And if you do that, then you get 1 to 1.5. Well, you can't have that. You can't have a half. So the easiest way to get rid of that half is to double it. And if I double it, then that becomes a 3, and that becomes a 2. So, oh yes, that's right. It's a 2 to 3 ratio. That was one of our other choices. The 2 to 3, which is the same thing here, 2 to 3, which is the 1 to 1.5 that we just saw. But in whole numbers, that's 2 to 3. Our last problem here, number 4, is really no different than the other ones. It just looks a lot scarier because they're going to make you earn the concentration here. So they're telling you that you've got a colored solution of vanadium, and you are going to examine 50 milliliters of it, and it's found to have an absorbance of 0.20. Now, they didn't give you an equation or anything, which is fine, but you can guesstimate from the graph here what that 0.20 is doing for you. So if this is your absorbance at 0.20, then you go over until you hit the line, like so, and then you go down, like so. And it looks to me that your concentration is pretty much right in between the 0.04 and the 0.06. So I'm going to call it easy, and I'm going to call it 0.05 molarity, just to make my life easy for this guy. So our absorbance is about 0.2, but that translates to a 0.05 for your molarity. So remember, what we're trying to do is the same thing that we did before. We have vanadium phosphate over here. So I'm going to have vanadium X and phosphate Y over here. And I want to know what the charge of the vanadium is. So no worries, I just need moles here and moles there, and I'm good to go. But now I know that there are 50 milliliters of this vanadium, but I don't care that its absorption is 0.20. I care that it's 0.05 as far as its molarity is concerned. So the vanadium is going to be 50 milliliters of 0.05 molarity. So if I know milliliters, I know liters. If I know molarity in liters, I know moles. We've seen this movie before. So this is going to be 0.05 liters at 0.05 molarity. So molarity is equal to moles per liter. So I'm going to have 0.05 molarity is equal to the moles per 0.05 liters. So I have 0.05 and 0.05, that's 0.0025. So as far as the vanadium is concerned, I have 0.0025 moles. I can take that number and shoot him right up here, because I now know the moles of the vanadium. So 0.0025. All I need to know now is the moles of the phosphate, and I am good to go. Well, what did they tell you? They told you that you precipitated everything, and you precipitated it with enough phosphate to give you 0.285 grams of the vanadium phosphate here. So just like we saw before, if I have 0.285 of vanadium and phosphate, and I can subtract out the grams of the vanadium, that'll leave me with the grams of the phosphate. So how do I get the grams of the vanadium? Well, you already know the grams of the vanadium. You just have to work it out, because you know how many moles of vanadium there are. So you get on the periodic table, and you realize that vanadium has a mass of 50.94 grams per mole. So 0.0025 at 50.94 gets you 0.127 grams of vanadium. So I am going to subtractify out the 0.127 grams of vanadium. So 0.285 minus the 127 gets me a 0.158 grams of the phosphate. If I know the grams of the phosphate, then I know the moles of the phosphate. All I have to do is divide it by its molar mass. So it's going to be 1 mole per 95 grams. Phosphorus is 31, oxygen is 16 4 times. So add all that up and get you 95 for that ion. So divide that guy out and you end up with 0.00166 moles of the phosphate ion. That number there gets moved all the way back up to our top here. So this is now 0.00166. These are not the same numbers. So we got to figure out what their whole number ratio is. You divide by the smaller of the two numbers. So 0025 divided by that there, and you get a 1.5 to 1 ratio. This sounds familiar. So this is 1.5, and this is 1, which really means if it's a 1.5 to 1, I can't be a half, so I have to double that up to 3, which means I have to double that up to 2. So my correct formula then is V3PO42. So what is the charge of the vanadium? Don't say 3, because remember, if we look at these from their ion perspective, it's going to be the vanadium with the phosphate, and we know phosphate is a -3, which means the vanadium must be the +2 in order to end up with this formula down here, to crisscross those down, to end up with the 3 and the 2. So what charge is the vanadium? The vanadium must be a +2 charge.